One more example. There's a lot of videos here. Not a lot of videos, but a lot of time. One more example. 2 cotangent of x minus pi over 2 plus 2. It's a cotangent. Cotangents and tangents follow the same pattern, essentially. I want to graph the same 4 ones I always graph, the same 5 ones I already graphed, the points on the axes. And I want to throw in the pi over 4 points for my argument. So my arguments are 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Is that 9 of them? 1, 2, 3, 4, 5, 6, 7, 8, 9. And what x value is going to give me that argument? This argument is this, right? X minus pi over 2 needs to be 0. X minus pi over 2 needs to be pi over 4, and so on. So what have I got? Let's do the arithmetic on another sheet of paper. Grab one. I want the argument, the thing circled in blue here, I want it to be 0 when I'm done. Plug in an x, subtract pi over 2, I ought to get 0. Plug in an x, subtract pi over 2, I ought to get pi over 4. What does that mean? I want x minus pi over 2 to take on one of those nice argument values. That's the easiest one we've solved lately. X would have to be a plus pi over 2. I just need to add pi over 2 to the argument to get what x would need to be. So I'm going to go down and add pi over 2. 0 plus pi over 2, pi over 2 plus pi over 2, pi over 4 plus pi over 2, pi over 2 plus pi over 2, half of pi plus half of pi. 3 pi over 4 plus pi over 2 is 5 pi over 4. 1 pi plus 1 half pi is 3 halves pi. This is 7 pi over 4 if you add pi over 2. 3 pi over 2 plus pi over 2 is 2 pi, because it'd be 4 pi over 2. 7 pi over 4 plus pi over 2 is 9 pi over 4. And let's see, 2 pi plus pi over 2 is 5 pi over 2. Okay. Cotangent of x minus pi over 2. If I plug in this x, the argument, the x minus pi over 2 is going to be those numbers. Now remember, cotangent graph kind of looks like the tangent graph, but the places where the cotangent is undefined are different. And it kind of swoops backwards from the tangent graph. My unit circle is on this table somewhere. Notice that the cotangent is undefined not at the top and the bottom, but at the right or the left, because cotangent is cosine over sine. And the sine is 0. So the cotangent would be 0. So at 0, the cotangent is undefined. I'm sorry. Yeah. And if the argument turned out to be pi, the cotangent would be undefined. And in fact, when the argument turns out to be 2 pi, the cotangent is undefined. Right? So if I plug in x and what comes out is either 0 or pi or 2 pi, the cotangent will be undefined. Cotangent is undefined here and here, whereas the tangent's undefined at the top and bottom at 3 pi over 2 and pi over 2. Now, let's see. If I plug in 3 pi over 4 for x, what comes out is pi over 4, and the cotangent of pi over 4 is 1. If I plug in pi, what comes out, pi for x, what comes out here is pi over 2, and the cotangent of pi over 2 is 0. Plug in 5 pi over 4, what comes out is 3 pi over 4, and the cotangent is negative 1. And then we do the same thing again, 1, 0, negative 1. And then we can plot those points and get a graph. Let's see, what kind of graph do we want? Axes. Ooh, that was really bad. Okay. There's pi, 2 pi, 3 pi, 0, negative pi, negative 2 pi, negative 3 pi, and then just, I usually do my numbers like that. Okay, 1, 2, negative 1, negative 2. Okay. First thing I'm going to do if I'm graphing a tangent or a cotangent is to figure out where those asymptotes are. They're at, if x is pi over 2, there's an asymptote. So halfway to pi. Take my ruler, put it down, sketch that asymptote. Okay, let's see. At pi, if x is 3 pi over 2, that's 1 and 1/2 pi. So here's another place. Okay, let's see. And then at 2 pi, if x is 5 pi over 2, if x is 5 pi over 2 is another place it's undefined. Then let's plot the rest of the points. At pi over 4 here is 1. At pi, it's 0. At 5 pi over 4, oh, that messed up there, folks. That I looked at the argument, not the x value. Go back. The argument is 3 pi over 4. At 3 pi over 4, that's here, the value is 1. And at 5 pi over 4, the argument's negative. The value is negative 1. If the x is 3 pi over 2, that's here. Oh, it's undefined. Got it. At 7 pi over 4, it's 1. At 2 pi, right there, the value is 0. You know what? Back completely up. I'm not done, and you're probably wondering what in the heck I think I'm doing. I haven't multiplied by 2 and added 2. 2 cotangent of x minus pi over 2 plus 2. I still have to multiply by 2 and add 2. Still undefined. 2 times, so that's 4. 2. 2 times negative 1 is 0. Right? 2 times negative 1 is 2, plus 2 is 0. Undefined. 2 times 1 is 2, plus 2 is 4. 2 times 0 is 0, plus 2 is 2. 2 times negative 1 is negative 2, plus 2 is 0, and then undefined. Now, let me pick out a different color pen so you don't confuse those wrong ones that I did just a minute ago. I think I'll plot them with the orange Sharpie. If x is 3 pi over 4, y is 4. If x is, let me circle the x's. If x is pi, there's pi, the y value is 2. If x is 3 pi over 4, the y value is 0. And notice, these things are asymptotes, the black lines, right? These dotted lines, asymptotes. So the cotangent function comes in here, goes through these points, and then down. And then, let's see, where are we? That was 3 pi over 2. The next one, 7 pi over 4, the value is 4. It's up here. At 2 pi, the value ought to be 2, right there. And then 0, and then that graph. Copy and repeat, right? Just, it's periodic. It's going to do the same thing over and over and over and over and over because it's periodic.